For my challenge project, I've built a programmable Galton board using Python and Lego. Unlike most Galton boards which have a fixed probability of 0.5, with this Galton board you can choose any probability from 0 to 1. This project consists of about 80 lines of Python code, over 1,000 Lego pieces, and I've open sourced the code and building instructions so that teachers and enthusiasts everywhere can use this as a learning tool. Before we start, let me introduce you to my co-star, Oliver.
Hi!
Oliver, do you know what this is?
Yes, it's a Galton board.
This particular Galton board is built with 10 levels. Each level has its own motor. Motors are controlled by Lego Spike Prime hubs, which are just little computers with convenient APIs for motors and other components. Do you know what distribution a Galton board produces?
Yes, it's a binomial.
That's right. N is equal to the number of levels or left-right decision points. We get to set P. Just for fun, I'll set it to 0.45. Each of the bins on the bottom represents a different value of K, and each ball that travels through the device represents an IID random variable. So after putting 100 balls through the Galton board, what we'll see will be a realization of a sample of size 100 with samples drawn from a binomial distribution parameterized by n equals 10 and p equals 0.45. Got that?
This is going to be awesome.
Let's see it in action.
This kind of looks like a normal distribution. Is that because of the central limit theorem?
Yes, it's not a perfect approximation with this n, but you can see a general shape emerge.
Can I look at the code?
Here it is. You can set your p using a constant. The main functionality uses nested loops for each ball and for each level that the ball traverses. A motor rotates based on the outcome of a Bernoulli trial.
Did you use SciPy to do the Bernoulli trials?
It turns out you can't import arbitrary libraries onto the hub, but it was super easy to make my own Bernoulli function.
What's the simulation mode?
Check it out. This performs in mock runs, so you'll know what to expect.
What if my school wants to build a Galton board?
Yes, imagine your school wants to build a big Galton board with 20 levels and 200 balls. They can get an idea of how big they should build their bins.
What about the build instructions that you made?
I learned to use Brickling Studio specifically for this project. I'm not gonna lie, it was kind of annoying precisely placing over 1,000 bricks and hand editing steps so they could be in a logical order for the 719-page instruction manual.
Why did you do it if it was annoying?
I really wanted teachers and students to be able to replicate this. It's one thing to show a cool demo on TikTok, but it's another thing to be able to build and customize a device and use it as a tool to feel probability distributions.
That makes sense. Hey, can we play a game?
Sure.
I'm gonna choose a single probability, and then you're gonna have to guess.
What? We're gonna run the board and I'm gonna have to guess?
Yeah.
Let's do it. Counting how many balls there are in each bin and taking the average value of x across all these observations, I get 1.67. There are 10 levels and mu equals np, so my best guess for p is 0.167.
While I appreciated this unbiased estimator, I was hoping for more of a range.
Great point. Let's calculate sample variance, standard error. I think p lies between 0.088 and 0.246. What's the right answer?
0.18. That's within your confidence interval.
Yay! Central limit theorem!